In this class, we're going to do a lot of manipulation of logarithms and exponential functions, okay? And several of these relationships we're going to use a lot throughout the semester. And what I want to do is help you understand them by applying them to some very simple applications. So here I have a to the m times a to the n equals a to the m plus n, okay? This works for any base. You might use base e for natural logs. You might use base 10, and then if you just have a log and you don't put the base below it, you're implying log base 10. So let's apply this to something we can understand, okay? I think everybody in this room could do 100 times 1,000. So I could say 10 squared times 10 cubed is equal to 10 to the 2 plus 3. Now let's check that out, okay? 10 squared is 100. 10 cubed is 1,000, and 10 to the 2 plus 3 is 10 to the 5th, which with 5 zeros is 100,000, and 100 times 1,000 is 100,000. Now, if I come and express this in logarithms, I'm saying 10 to what power equals a number. So if x is 100 and y is 1,000, then I can say that the log of 100,000 is equal to the log of 100 plus the log of 1,000. Now, 10 to what power is 100,000? Well, that's 10 to the 5th. So the log of 100,000 is 5. 10 to what power equals a number. Here I have 10 to the power of 2 is 100, so the log is 2. And 10 to the power of 3 is 1,000, and lo and behold, 5 is 2 plus 3. Okay? So hopefully you can see that this is not magic and it's based on this. Now let's come over here and look at a to the m over a to the n. Okay? Let's choose some simple numbers. Let's do 1,000 divided by 100. Okay? So 1,000 is 10 cubed. 100 is 10 squared. 1,000 divided by 100 is 10. And 10 cubed divided by 10 squared is 10 to the 3 minus 2, which is 10. So 10 equals 10. Okay? Now let's look at it this way here. If I take the log of 1,000 over 100 is equal to the log of 1,000 minus the log of 100. Now, 1,000 over 100 is 10, right? And the log of 10 is 1. 10 to what power equals 10? 10 to the power of 1. And this is equal to 10 cubed is 1,000, so the log of 1,000 is 3, minus 10 squared is 100, 2, and lo and behold, 1 equals 3 minus 2. Now, another relationship you're often going to use is if I'm after something in an exponent, okay, and I've solved something and my exponent is what I need, then an easy way is to take the log and then do this relationship, okay? So let's try this one. Let's do 100 times 100, okay? So if I say 100 squared, does everybody agree that that's 100 times 100, which is 10,000, okay? Now, I could say that the log of 100 squared is equal to 2 times the log of 100, which is 2 times 2, which equals 4, because the log of 100 is 2, and 2 times 2 is 4. Now I can come over here and say the log of 100 squared is the log of 10,000, and 10 to the power of 4. So the log of this is 4, and lo and behold, 4 equals 4. Okay? So the log of a to the b is b log a. Okay? All right, I hope that helps. The important thing is to be able to fluently manipulate your equations, and you're going to need this one a lot because anytime you're solving for something in a exponent, you need to take the log. And we don't usually use log base 10. We often use natural log. These relationships occur for any base. I'm using log base 10 because these are numbers that you can intuitively see. Okay?